In this video, we shall discuss the test of significance of difference between the standard deviation of a large sample and the standard deviation of the corresponding population from which the sample has been drawn. So suppose S be the standard deviation of a large sample of size n greater than or equal to 30 drawn from the normal population with standard deviation sigma. Then standard deviation S follows the normal distribution with mean sigma and standard deviation sigma upon root 2n approximately. This is the test statistic for testing the difference between the sample standard deviation S and the population standard deviation sigma, and every other things will remain the same. That means the null hypothesis, alternative hypothesis, level of significance, critical values, and the procedure, they will remain same as we have discussed in case of other large sample tests. So take an example. In a certain sample of 72 items, the standard deviation is found to be 8. Is it reasonable to suppose that it has been drawn from a population with standard deviation 6.5? If not, find the 98% confidence interval for the standard deviation of the population. So if we note down the data, here sigma is 6.5, population standard deviation, sample standard deviation is 8, and sample size is 72. Now suppose H0 is S equal to sigma, that means the random sample has been drawn from the population with 6.5. That means there is no difference between the sample standard deviation and the standard deviation of the population. H1 we set as there is a difference between the sample standard deviation and the population standard deviation. That means the random sample has not been drawn from the population with standard deviation 6.5. Here level of significance is 2% and the critical value corresponding to this level of significance is 2.33. So total 2% area on either sides will be the critical region. So this is 1% area corresponding to 2.33 and this is minus 2.33. This is the critical region and 98% area is here. So this is the acceptance region. So critical region is outside minus 2.33 and 2.33. So what is the value of test statistic Z? S minus sigma upon root 2n, which is found to be 2.769. So if we compare this value with the critical values, we find that this value lies outside this acceptance region. So this 2.769 is somewhere here. So H0 is rejected and H1 is accepted. That means the random sample has not been drawn from the population with standard deviation 6.5. So here H0 is rejected and H1 is accepted. Now here we see that on the basis of sample, the standard deviation of the population cannot be 6.5. Then what it should be? This can be found by the confidence interval. So 98% confidence interval of the population standard deviation is obtained by this formula. That means we have this computed value of Z should be less than Z at 0.02. That means this S minus sigma upon standard error of S, this should be less than or equal to 2.33. So from here we get this interval. It is 6.73 to 9.26. So standard deviation of the population must be in this interval, but the standard deviation is given as 6.5, which is outside of this interval. That's why we have obtained difference between the sample standard deviation and the population standard deviation significant, and we have rejected H0. Take another example. A manufacturer of electric bulbs, according to a certain process, finds the standard deviation of the life of lamps to be 100 hours. He wants to change the process if the new process results in a smaller variation in the life of lamps. In adopting a new process, a sample of 150 bulbs given a standard deviation of 95 hours. Is the manufacturer justified in changing the process? Test at 5% level of significance. So manufacturer will change the process if he finds that the standard deviation is less than 100 hours. So here if you note down the data, here population standard deviation is 100, sample standard deviation is 95 and sample size is 150. So here if we set H0 as there is no difference between the standard deviations of the sample and the population. That means the new process does not result in a smaller variation, and H1 as the new process results in a smaller variation. Now here level of significance is 5%. Therefore critical value corresponding to this 5% is minus 1.645 on left, because we have to use left tail test. So this is the critical value. That means 5% area on the left side, 1.645. So this is the 5% area on the left side, and this is the region of acceptance. So if we compute the value of Z, it is minus 0.867. So this minus 0.867 is falling in the acceptance region, because this is minus 1.645 is the value separating this critical region with the acceptance region, and this value falls in the acceptance region. Therefore H0 is accepted That means the new process does not result in smaller variation. Therefore, the manufacturer should not change the process. Take another example. In a random sample of 200 items drawn from the population with standard deviation 0.8, the sample SD is 0.9. Can we conclude that the population SD is less than the sample SD? If yes, find the 99% confidence interval for the population SD to be regarded same as the sample SD. So here, if we note down the data, sigma is 0.8, which is population standard deviation. Sample standard deviation is 0.9 and sample size is 200. So here we set H0 as the sample standard deviation and the population standard deviation are the same. So S equal to sigma. And here H1 we set as sample standard deviation is greater than the population standard deviation. That means the population standard deviation is less than the sample standard deviation. Here level of significance is 1%. So corresponding value is 2.33. That means this is the critical region corresponding to this level of significance. This is 2.33. So 1% area on right hand side. This is the region of acceptance. So if we compute Z, we find that it is 2.5. This value 2.5 is falling in the critical region. Therefore, H0 is rejected. That means population standard deviation is less than the sample standard deviation. Now what should be the population standard deviation so that H0 is accepted? So we find the 99% confidence interval for the same population standard deviation. Now the 99% confidence interval for the standard deviation of the population is when Z less than or equal to 2.33. That means Z should fall in the region of acceptance. So this value is 2.33 and the computed value 2.5 is falling here. That's why H0 was rejected. Now if H0 is to be accepted, computed value must lie in this interval. So for this we find Z less than or equal to 2.33, which on solving gives sigma greater than or equal to 0.806. Therefore the population standard deviation must be greater than or equal to 0.81 while it is given as 0.80. That's why H0 was rejected. So population standard deviation must be greater than or equal to 0.81 so that we can regard the population standard deviation and the sample standard deviations as the same. Now we discuss the test of significance of difference between two sample standard deviations. So here S1 and S2 be the standard deviations of two large samples of sizes n1 and n2 respectively, drawn from the normal population with same standard deviation, drawn from the normal population with standard deviation sigma. So S1 follows normal distribution with mean sigma and standard deviation sigma upon root 2 n1, which we have seen in the previous test, and S2 follows a normal distribution with mean sigma and standard deviation sigma upon root 2 and 2. Therefore, this difference S1 minus S2 will follow the normal distribution with mean 0 and standard deviation is sigma into under root 1 upon 2 n1 plus 1 upon 2 n2. Therefore, the test statistic will become, because expectation of S1 minus S2 is 0, that means mean is 0. So, this is the test statistic for testing difference between two standard deviations. In case sigma is not given, that means population standard deviation is not given, then we can find an unbiased estimate of sigma using this formula. And if we substitute this formula in the formula of Z, we find that the simplified formula for the test statistic in case sigma is unknown is this. So let's take an example. The standard deviation of a random sample of size 1000 is found to be 2.6 and the standard deviation of another random sample of size 500 is 2.7. Assuming that the samples to be independent, find whether the two samples could have come from populations with same SD. So here S1 is 2.6, N1 sample size 1000, S2 2.7 and sample size N2 500. This is N2 500. So let H0 S1 equal to S2 or equivalency sigma 1 equal to sigma 2. That means the two samples have been drawn from the same population. That means the two samples have been drawn from the populations with the same SD. H1 S1 not equal to S2. That means the two samples could not have come from populations with same SD. Alpha is 0.05 by default and critical value corresponding to is this level of significance is 1.96. So here we have to use two-tail test. So this is the critical value 1.96 and this is 1.96. So minus 1.96 to plus 1.96 we have the region of acceptance and outside of this we have critical region. Since sigma is unknown, therefore we have to use this formula and this value is found to be minus 0.98. So if we compare this value with the critical values, we find that this value falls in the region of acceptance. this value is falling somewhere here. So this value lies in the region of acceptance. Therefore, H0 is accepted. That means two samples could have come from populations with same standard deviation. That means the two standard deviations can be regarded as same. So this was the test of significance of difference between standard deviation of a large sample and the standard deviation of the population. I hope you understood what I have told you. Thank you very much.